I think the reality is, as long as we continue to invest in bright minds and getting people working on these solutions like we have been doing for some time, I do believe that we're going to get to that outcome anyway.
Mhm.
It may take, it may be in a different sort of time scale, but these are relatively short time scales. But I think the positive news is those types of technologies win in the long run, no matter what.
Welcome to Care More, Be Better, a podcast for people like you who care about the social impact of conscious companies and everyday heroes. Hear inspiring stories from those who put people and planet before profit and personal gain. You'll learn how you can make a difference, vote with your dollars, and get involved today. Here's your host, Corinna Bellizzi.
Hello, fellow do-gooders and friends. I'm your host, Corinna Bellizzi, an activist who is passionate about social impact and building a better, more sustainable future. Every week, we invite you to care a little bit more so that together we can all be a little better. And today we're going to deepen our understanding of all things energy as we're joined by Jesson Bradshaw. Jesson is a CEO of Energy Ogre, an electricity management company that uses proprietary systems to ensure its customers are always getting the best prices on their energy and electricity. Energy Ogre has helped over 100,000 Texans save up to 40% on their electricity bills, over $150 million since its founding. Jesson, welcome to the show.
Hi there, Corinna. Thanks for having me.
Well, it's so nice to have you here. I am always concerned with energy consumption. It's something that I probably spend more time thinking about than most people do because I see the effect it has on our communities around the globe. And even in Texas, when last spring there was an ice storm that resulted in people being without power for a long, long time. I think it was a stretch of about 7 or 8 days in some communities. So I wondered first, what got you into this space of working in energy? And second, what makes you passionate to continue forward in it?
Sure. Well, I think a lot of people have their, forays into things where they don't really know what they want to be when they grow up. And so I kind of figured it out now, but I guess, I got into electricity, specifically power, by very much being in the right place at the right time. And so it was happenstance versus, me very specifically trying to, chart out a course in that particular industry. But, the federal level, there was some big changes that were happening in terms of deregulation at the federal level that began in the early 90s and really started to come into effect in the mid 90s. And that's about the time that I was coming out of school and just so happened to find myself in this industry that was just really becoming, a big thing. We always use electricity. And so the utility business was around, for 60, 80 years beforehand, or longer in certain cases. But really the newer form of what we're dealing with today and the pace of technological change that we're dealing with in this space, a lot of it, I think, has gone back into the late 80s, early 90s. And so that's kind of where I started. And it's been a heck of a fun ride. It's exciting to me because, when I first started in this space, it was the most recent deregulated, big federal, national deregulation that had occurred. Prior to that, we had airlines, and that was a huge win for consumers in terms of reducing prices and increasing access. And then, we had telecommunications. And so, telecommunication deregulation would change the world type of change. And so electricity was the next on that path. And, a lot of these cases, when you start that, you kind of get to this point of equilibrium relatively quickly. You get rid of a lot of the inefficiency, you increase access. But power is one of these interesting things because of its very nature and the way we actually deliver it and we generate it. It's constantly undergoing an evolution. It's undergoing an evolution in terms of, folks spending more time thinking about where their energy is coming from. But at the same time, we have some regulatory change that's occurring. And I think probably most importantly, we have a tremendous amount of technology and technological innovation that's occurred over the course of the last 15 or 20 years. And the pace of that's just accelerating. So it was super interesting when I got involved with it, almost 30 years ago. And I find the pace of change and the impact that it has it just kind of keeps my interest level because it's constantly changing and evolving.
Well, I recently featured the story of Manik Suri, who is the CEO of Therma, and they're trying to attack energy usage in the refrigeration sector, specifically fixed location like refrigerators at retail shops and restaurants and things along those lines by improving their efficiency and essentially ensuring that they're not sitting there using energy that they don't need when they don't need it. And so I wondered how specifically Energy Ogre has reached this objective of reducing energy usage by 40% or reducing their bills by 40% for people of Texas. Like, how did that actually happen?
Well, many people in different parts of the country don't have a choice in their providers, and they don't have a competitive landscape. And so most parts of the country, we still have a monopoly provider
I'm
that
sorry, you're preaching
has,
to the choir here. It's PG&E in California. And like, I can't get away
right,
from them if I want to. Like I installed solar, but it was recommended that I feed up the line to PG&E, so we're still connected. And if something goes wrong with the solar, I would still have power serviced at the house. And let's just say it's not an easy relationship. Um,
right. And that's what you see is, it's interesting because the competitive market for the areas of Texas that actually have retail competition has been a huge win for consumers. It's always hilarious to me, kind of being in the weeds on this stuff, that there are always folks that really want to like hammer deregulation or the competitive market. But the fact of the matter is that here I am 20 years post deregulation in Texas, and I paid probably equal to or lesser than what I paid when we were still regulated for my electricity service over 20 years later. So
wow.
huge windfall for consumers. So in our market, we have, over 140 different providers that are registered to be able to sell electricity at retail. So there's a smaller number of those that are actually active at any given time, but it's a very robust competitive market. And one of the things that's nice about that is, in the old days here, and in some of the places, your audience might, what my situation is, but a lot of times it's a one size fits all.
Mhm.
If you're taking residential service, you're taking this kind of residential service, and that's the way it is. And in the competitive market, if you wanted to be, if you're the kind of person that works shift work or something like that, and you really you're optimized around very low nighttime consumption and higher daytime consumption, then there's a plan that might exist for that. Or if you were super focused on solar, if you want to put batteries in place, whatever the case might be, is you definitely have, it's that old Burger King have it your way type mentality where the market figures these things out and provides the right economic incentive to drive consumption behavior, right? So a plan that's, free nights and weekends, like we used to remember in the cell phone days way back when. Well, those types of plans exist here. And what it does
Limited
is
texting.
yeah, so it incents people to consume in some of these non-peak periods of time. And so there's it's one of the things that the industry has struggled with a lot is how do we signal consumers to change their consumption behavior based upon what it costs, not only in terms of the fuel costs and economic costs, but emissions costs, et cetera, for consumption during different times of the day. So, and there's many periods of time here, just like, you would see out west a long time ago, where a lot of the marginal power that's being generated in the West, there were a number of hours where it's mostly hydroelectric generation.
Mm.
And so you would want to incent more consumption during those periods of time because you have a surplus of capacity during those hours, and other periods of time you'd like to have people shift their consumption behavior. So those things exist here, and that's what Energy Ogre does is we look at the unique consumption profile that each one of these customers have and try to find the right kind of program for them that really is optimized around the way they use electricity.
So you mentioned hydropower, which is, of course, a green form of energy, along with solar and wind and a few others. I would really love to know in your area, maybe if we could just take it there where you're more expert, How
Sure.
close are we to 100% renewable energy? And what might it take to just get over the hump and actually be there?
Sure. Well, in Texas, I mean, a lot of people, I think, outside of Texas and a lot of people who are Texans don't really understand where we are. So Texas is its own separate interconnection. It's electrically separate from the rest of the country. It's not the entirety of the state, but it's the bulk of the population centers in the state. And, Texas is the fifth largest producer of wind energy in the world. So we're behind Germany, India, China, the United States, but we're in the United States numbers. And there's one other country I can't remember, but we're a humongous producer of wind energy. So much so that looking at these numbers last year in 2021, 24% of all the electricity that was consumed in Texas came from wind. And so it's just a huge fraction of our generation mix. We had 4% of our generation last year came from solar. So we have well over a quarter of our energy that was actually produced last year came from renewable resources directly. We also have many thousands of megawatts of new generation projects that are currently in construction or in the middle of construction. Or beginning construction, I should say. And so, of our overall nameplate capacity in Texas, what our theoretical generation maxima would be, if we have over 90,000 megawatts of generation capacity, about 30,000 megawatts of that, 35,000 megawatts, that's wind. And we have about 10,000 megawatts by year end of solar. And that number, depending upon what you want to believe from a projection perspective, that number is going from anywhere upwards of 18,000 to maybe over 25,000 megawatts of solar. So Texas is very, very much on the forefront, well beyond the bleeding edge of deploying renewable resources. And that comes with a serious set of challenges. All of these assets are not created equal. Much of our wind capacity exists in far west Texas, and it has an output profile that's not always ideal for the way people consume electricity. There's a lot that's produced in the early morning hours and the late afternoon, late evening hours, whereas the bulk of our consumption occurs across the middle of the day. So we don't really get as good of an overlap between those two assets, but the solar really works out well. It's complementary in many respects. So those two seem to work pretty well, and it'll be interesting to see how this moves forward. But, in my opinion, from what I see today, just the nature of how electricity currently, with the state of the technology, electricity is one of these weird products. It's unlike anything else we consume. It's produced, distributed, and consumed instantaneously. It all happens at the speed of light. And outside of a few types of technologies where we convert electricity into other kinds of energy, to store it, to reconvert it back to electricity, generally speaking, that capacity is very, very limited. And so our ability today, we would not have the ability to reliably move to 100% renewables at the current state of technology in Texas or really anywhere else. Maybe certain parts of the Pacific Northwest where they have a capability set that's large enough to handle all the load and it's dispatchable enough. But we need to overcome the issues that have our renewable resources today tend to be non-dispatchable.
Okay, so storage isn't really happening is what you're getting at.
Right. We're not quite there yet. And that's the place that I expect to see some of the biggest, there's the biggest economic incentives to develop some of those technologies. And that's where I see, in addition to us, generating electricity on a cost-effective basis, I think that's the next place where I really expect that we'll need to see technology lead the way.
I mean, there are instances where, from a tech perspective, you can use like a water pump perspective where, if you have that hydroelectric ability, it's pretty constant because the river continues flowing, right? But then I've even seen some systems where you pump water up when there's surplus and it comes down when there isn't. And so you continue to have kind of that energy output. but not all systems are like that. Like wind, I think you'd have to have an incredible battery backup in order to keep enough energy stored to be able to help people through the peak usage of their day, correct?
Right. And you rightly point out in certain parts of the country, there are several that are in the Northeast, very large pump storage facilities, and those were largely built around there being massive surplus of electricity generated from nuclear power plants. So it provided a huge incentive to use the excess nuclear energy during the nighttime for use during the daytime. So there's some of those projects that are there. There's some in Georgia and in some other places, but you have to have a geography that allows you to do that. And, it's kind of destructive to the landscape as well to put a huge dam and create a massive lake where one didn't exist before. So there's a lot of other kind of considerations to contend with that. The state of the battery technology today is, there are definitely some grid scale battery technologies that are out there. There's a little over, looks like 1,000 or 1,200 megawatt hours of that I see in the queue here. And that's interesting. It's just this very small, almost doesn't scratch the surface in terms of actually covering load. So,
well, and it's also resource intensive because you have to have all those rare earth minerals, and the batteries don't last forever. They need to be replaced. And so I think that there's creative minds at work to find solutions to these things that may not be as taxing on the environment, because I think the problem with a lot of technology is that we don't know what the negatives are necessarily going to be until we get started, right? So like, is there going to be a shortage then of some of these rare earth minerals? And we're already confronting a lot of that when we're looking at the electric car space, because electric cars are booming, right? And more people are driving automobiles. And then suddenly we're melting permafrost in Greenland to get to rare earth minerals that we otherwise wouldn't have access to.
And I think that's all true. And the interesting thing is, I think that technologies need to be application specific. So, the lithium ion technologies made the probability or the actuality of being able to push an electric vehicle out that was viably. It has an appropriate energy density to its weight to make it work. The good news about grid scale power and grid scale storage is these are all stationary devices. They don't need to move anywhere. So some of the characteristics that we would use, like we don't need lithium ion battery packs to run grid scale storage. You can do it with much less expensive, much more environmentally reasonable. I was looking at some of these emerging technologies, some very interesting ones having to do with molten metals. And a lot of those molten metals, like you won't think calcium is a metal, but it's on the metallic end of the spectrum, on the element spectrum. But a lot of those things you can be very, very environmentally conscious around because you can pick them up in sight. So you don't have to transport these things. You might be able to find them and create them in recycled materials that exist, whether it be iron out of the ground, whether it be calcium, et cetera, et cetera. So I do think that technology and the advancements of technology and the commercialization of those technologies is going to be a very, very important feature with us actually being able to achieve some of the goals that we're talking about here today.
Wow. Well, I'm curious to learn more about calcium being used as a metal and battery storage. I mean, I mostly know it from nutrition products and thinking about your bone density. Yeah, that's kind of incredible. Great.
Yeah, it's very interesting. I was reading and watching some information. There's a professor, I believe, is at MIT. They developed a molten metal. So they use salt as a membrane between the anode and cathode side. But you run them up, you get them melted, and it has a very interesting cycle associated with it. So I'm very interested to see that. And those are the kinds of things that we would be looking to see. Those would be the kinds of changes that we would expect.
Yeah. And we did cover some of that earlier on this podcast when we talked about Paul Hawken's regeneration, ending the climate crisis in one generation. He talks about some of that budding technology, which to me in some cases just seemed like science fiction. Like it seems so far from attainable at this very moment. But the reality is that advancements are being made, and some of the brightest minds of every country in the world are working on this problem. So if we can find a better way to store energy, then suddenly it's like, the vision that we have of being able to get to 100% renewable energy is much less a pipe dream and more a reality. So I'm encouraged by that.
Oh, I totally agree. I think that, folks often ask me, what's the future of renewables and how will they fit? And, is it, because they're non-dispatchable, are the issues that we saw in Texas in February of 2021, are those the fault of renewables? Or those the portions of the system that failed? And, I don't think the answer, that certainly can't be said. It's not a fault of one particular aspect of the system. But what I see happening is this very interesting step change that's happening in the energy space. And it kind of came from me looking at the way telecom evolved. Telecommunications is an interesting business that if you look at telecom, most of the cost of putting infrastructure in place, it's fixed costs. It's putting the fiber in the ground. It's putting all the switch gear that's in place. And those are very heavy capital items. But the cost to actually move data, the cost to move a photon, is pretty small. It's a very low variable cost. In power generation, it was kind of usually the other way around. Some, with the exception of nuclear, a lot of the other plants, if you looked at their entire cost of operating a plant over its entire lifetime, 85, 95% of those costs are going to be fuel costs. And so, it's still a big number, but relative to the total cost over the lifetime of that asset, a lot of it's going to be in fuel. And what's happened with the renewable technology is their variable cost of generating their fuel is free. And so it starts to look like we are getting into a business structure or an environment structure here that starts to resemble more the telecom business model than the legacy energy generation or power generation model. And all those things have happened because of advancements in material sciences and other types of technologies that, the amount of energy that's squeezed out of, a certain amount of photon energy from the sun, we see this change in the efficiency and the viability, the commercial viability of these technologies as we have massive advancements in all these things. And that's your point. It's absolutely correct. We have this unbelievably fast pace of change that's occurred in this space. And my kids kind of chuckle about this sometimes, but I keep reminding them when I started working in 1995, and 1995 doesn't seem like it's that long ago to me. But
that's just because you're old.
But we didn't.
I'm just joking. I graduated in '94 from high school, and so to me, I'm like, yeah, that was yesterday.
But we didn't have the internet at the office.
No, we didn't.
Yeah, we had emails. Yeah. And
how did I do my thesis in school? I think I had a 386 computer. My kids don't even know what that was.
Right. And so that, I know that we sort of would think that way, but it really hasn't been that long. And you start looking at, solar cells have been around for a very long time. Commercially viable solar that can compete pretty darn close with other traditional forms of generation, particularly in, your neck of the woods. That's a relatively new phenomenon. That really has to do with some breakthroughs in the material science, as well as some of the manufacturing techniques associated with these things. The technology, I don't mean it in terms of people think of technology as something new, but a lot of it has to do with perfecting and enhancing and commercializing these ideas, making them real, making them things that we get to put in our hands on a day-to-day basis. Even something as ridiculous as the iPhone, when did those come out? 2006? And now, it's kind of ubiquitous in terms of what we have. So we just don't think about how fast some of these things are actually changing. And the pace of this is moving very rapidly. So I think we're getting to a point in the energy space where, in power production specifically, as we continue to have advancements in material sciences, whether that's around better, stronger, longer lasting components for wind generation. We were able to remove points of failure like gearboxes and things of that nature that are in those pieces of equipment as they get easier to manufacture, as they become stronger, as we get more output in our solar cells themselves, as we develop energy storage technologies. it really does allow that to start to displace some of this historical generation profile. But it does that not just because it's getting some form of a subsidy to win. It will win on economics. And I think that's the thing that I think is heartening is as folks talk about, do something, do more, do it faster. I think the reality is, as long as we continue to invest in bright minds and getting people working on these solutions like we have been doing for some time, I do believe that we're going to get to that outcome anyway.
Mm-hmm.
It may take, it may be in a different sort of time scale, but these are relatively short time scales. But I think the positive news is those types of technologies win in the long run, no matter what.
That's great. So you mentioned something earlier that I'm not confident I understood, and that means I'm not also confident that everybody listening understood. You
Sure.
compared what's happening in the energy world to telecom. Now, is that because telecom is just networks of companies working together on the same platform? Is that what you mean by that?
So what I mean is, if I were building AT&T today, and I was, trying to sell data or sell internet service to folks, that business is one where I might have to spend $40 billion or whatever the number is building a bunch of infrastructure. But my cost, if you're signing up with me to be your internet service provider, my cost to actually move data across my network is very, very, very small. It's just the minimal amount of electricity that's needed
because the network is already there.
Right. The bulk of my cost to be in that business is putting all the infrastructure in place.
Right. So now I think I get it. I wanted to make sure that that was clear. And
Sure.
I really have been encouraged by even conversations around creating community-based energy sectors and things like that, so that we are kind of like more tightly knit collaboratives of companies or groups that are feeding energy into their homes and their businesses, as opposed to one multi-state conglomerate that gets to dictate everything of how energy is managed. I mean, what happened in my neck of the woods is that the solar was a great proposition a few years ago when the government was giving, rebates for it on things along those lines. And then also at that time, PG&E was paying more on per kilowatt hour than they are paying today. And so at the time that I got my solar installed, which was about 12 years ago now, I think it's been about that long, right? We got a significant cut in our taxes as a benefit. And then we were also getting paid at a rate that meant that it should pay for itself in 8 years, just as an example. But what they did with the repayment rate versus what they're charging is now shifted because enough people bought into solar because they had monopoly control. And so, there wasn't any market pressures on them to remain competitive. It's just, hey, we're the only show in town. You want power?
Right.
Which I think isn't the healthiest. It's not the healthiest for the consumer in the end.
Right. And that's really my big concern. And that's why I, love being able to speak to folks on a platform like yours, and why I love this format, because there is, I'm sure everyone that's, if you're a doctor and you hear people talk about medical stuff, you probably like grit your teeth and cringe, and so much stuff is said that is not really in keeping, or maybe it's not outright not true, but it may not be the entire story. And so I think all of us that are subject matter experts in the different areas of things that we deal with on a day-to-day basis, if we were to see them, we see other people talking about those things, you're like, that's not quite right. And unfortunately, I say that all the time in power. California is a good example of that. And so this is one of these things, I think, no matter what your goals are, whether they're well-intentioned, altruistic, or there's something more nefarious in play, a lot of people try to simplify these really complicated problems and act like they've got a solution. This is going to fix everything. And sometimes those solutions actually end up creating other problems. So like in California, for example, early in the adoption of solar, makes perfect sense. You are reducing demand on the system during the daytime hours, which is when most people are going to use electricity. But you can get to a point where you have so much solar that's sitting there that you end up creating this problem for the system. When in this transition period from daytime to nighttime, you're not really consuming a lot less electricity. You're just self-serving less of that electricity because your solar system is serving some portion of that.
Mm-hmm.
And so once the sun goes down, that demand is still there. So the amount that's required to come from the system explodes, and it creates a different kind of problem. And so by trying to put some things that are kind of non-economic, that are well-intentioned, sometimes it results in some things that I think are entirely predictable. And this is, when we have politicians and some other folks that are all of a sudden subject matter experts on energy, that's, I would say the same thing if they're all of a sudden subject matter experts on healthcare. They're not. And so we kind of have to be careful. And I see a lot of this. And, it really, I think what we have is a population, generally speaking, that's very, very sensitive to wanting to leave a better environment and a better place for, future generations. And so folks want to glom on to, solutions that they see. And sometimes those are great solutions. And sometimes they may be well-intentioned, but not really accomplishing what we wanted them to accomplish when it's all said and done.
So, your business is in Texas. I wonder how you're using your platform to push for change outside of Texas, or what your plans are with Energy Ogre as you continue to grow.
Well, I'm a huge believer in competitive markets. So there's been a massive opportunity for consumers in Texas that are in these competitive areas to be able to bring, if they want to put rooftop solar, or they want to have an incentive associated with that, or if they want to have different kinds of rate programs that incent innovation in new generation supply, things of that nature. That's what we're focused on here. And I do believe that we will see these pressures start to move into other parts of the country. It's one of the things I think, we're doing a very good job here of the proportion of our generation that's coming from renewables, showing that it can be done, showing that it's profitable for that to be done without massive, government subsidization associated with that. That consumers get a good deal. They're killing multiple birds with one stone, and we have a whole bevy of additional emerging technologies. We haven't even talked about getting into demand management or demand response to incent some of those behaviors on an automatic basis to be able to push these percentages even higher. So to me, competition and some of the liberalization of these markets works hand in hand with us getting into efficiency. And I think it's a real place where we're going to accomplish those goals. I think you'll start to see them in these markets first.
So let's talk for a moment about what people can do to minimize their usage during these peak times. If they have the ability to moderate their usage, like that they're not at a workspace where things are automatically taken care of for them.
Right. A lot of times, folks, some parts, Texas is a little bit different because I think we're pretty heavy energy consumers just because of our climate. Y'all have such, beautiful weather quite frequently throughout at least Southern California and other parts of the state. But, for us here, if we have a house that has multiple zones associated with it, then generally speaking, what we ask folks to do is to change their thermostat settings in the other zones or other areas, maybe a different floor of their house that they're not planning to get to. There's simple things you would think would add up to that much. One place that we see over and over again, this is definitely going to be the case in California, is a lot of times when folks come in and they do pool installations. They set the run schedules for their automatic pool cleaning equipment, and it tends to run right over the course of the top of the day.
Mm-hmm.
Whereas, it doesn't really have to happen in those timeframes. So you can schedule those maybe in the earlier morning and maybe in the late afternoon or something like that, depending upon when peak demand is in your particular area. One thing that people don't pay attention to that makes a big difference in terms of actual consumption on your HVAC system is changing the air filters. frequently changing your filters or changing them inside the settings is super important, because
It improves
those
the
systems will,
efficiency,
yeah, they
right?
will run much longer, and you'll consume way more electricity if you don't have clean filters. And so it's a very simple, easy, something everyone can do. But I think to this point, a lot of folks have probably done this, but a very easy one to do if you haven't done it already is to retrofit as much of your lighting as possible from incandescent lighting to LED lighting. It's amazing what the quantity of electricity consumption reduction is. LEDs are amazing. They last longer. They're actually not that much more expensive anymore, but I mean, you can have 10 lights on LEDs, and it's the same as one of the old incandescents would have been. So
And
they're
it's not as
pretty.
hot. So there's
That's
that
right.
too,
That's
especially
right.
if it's a hot summer and you're turning on all these lights. And
That's right. That's right.
yeah, that's great. Well, at this point in the conversation, I'd love to ask you if there's a question you wish I asked that I haven't. And if you have a question like that, go ahead and ask and answer that.
No, I think that the question that had asked before about, how can we get to 100% renewables, and I think that's such a laudable goal that I'm really optimistic around the continued application of some of these emerging technologies that will really allow us to get there, where they work on economics by themselves. So the biggest place to focus, I think, on the front end is going to be in some of these storage technologies. And there's so many smart people, and there's such a huge economic opportunity, and that can be anything from, as you said, from batteries is potentially one source, and I think we'll have a part to play in that. There's other technologies like compressed air energy storage, which is commercial technology, has been which is in use in certain parts of the world. That's pretty interesting technology, all the way through pump storage, like you had said, maybe up through even big flywheels, just converting some of that electricity into kinetic energy to be able to convert it back later. So I'm super optimistic that necessity being the mother of invention on these items, and it's fun to watch these things come into play when these new ideas come in the door, and we start to see them in the industry on basically something new almost all the time.
Well, I'm looking forward to the day when we can be on 100% renewable energy. I know that across the highway from me, some recent condos went up, and for a long time, they just emblazoned the sign 100% electric. And at the time, I was like, what does that mean? And why is that important? It's 100% electric. I mean, why would I care? I didn't understand that what they meant was that they were 100% electric and also 100% green energy sourced. And if they'd said that, it would have meant something much different. So perhaps they need a little bit of marketing messaging support on that arena. But I think as we continue talking about all of these things, of converting homes to be more energy efficient, doing things like addressing insulation or going to double pane glass and changing the filters in our home or altering when you plug your car in to charge it based on when peak usage is, all of those things can help us out and ensure that we don't have brownouts and things like that while we figure out what our energy infrastructure is really going to look like in this next generation. Because consumption just seems to keep going up, doesn't it?
It does, and I think you talked about even for periods of time when it goes sideways, the trend continues to move upwards, and I think that we're going to be facing a real problem not only with the generation of electricity here potentially, but also our infrastructure, our wires, and some of the others. If we get more and more adoption of electric vehicles, that's a pretty significant change in terms of how do we charge all of them? Is that, in-home charging? Is it centralized charging? A lot of homes don't have large enough amp service in a lot of parts of the country to be able to charge a vehicle as well as run all the stuff that was in the house otherwise. So there's some very interesting and unique challenges that I think, are forthcoming. But, again, big challenges present big opportunities as well.
That's right. Get those smart minds on it.
Exactly.
Well, thank you so much, Jesson, for joining me today. This has been a pure joy. I didn't expect to like learning more about electricity, and I did. It was
It's
really nice.
perhaps the most boring subject that I could have ever talked to people about before, but now all of a sudden it's interesting. So
I think perhaps I'm just a nerd. Thank you again, Jesson, for joining me. This has been awesome.
it's been great. I really appreciate the opportunity to speak to your audience and love the work that you're doing. And I hope that you continue to inspire folks along with what you're trying to get done.
Perfect. Well, I'll be sure to invite you on again when I need to talk about energy again. I'm sure something will come up.
For sure.
All right. Thank you. Now, listeners, it's time for that simple ask. It doesn't have to be huge. It doesn't have to be a Herculean effort. All it has to be is something simple, like sharing this podcast with people in your community that you think need to learn a little bit more about how we use our energy and the things that we can do to be more mindful of usage so that as we continue to grow, we don't enter a cycle where we can never get to 100% renewables. All of us have a role to play in that, and many of our brightest are already working on that project. Now, if you want to find out more about Jesson Bradshaw and also all the work that Energy Ogre is doing, just go to energyogre.com. And I encourage you to visit my website or just click on the links in show notes. If you do go to caremorebebetter.com, you will also find, if you join my newsletter, you'll get 5 steps to activate your inner activist. It just comes to you as your welcome gift, and that can help coordinate or organize any thoughts that you might have about the sorts of impacts that you want to make in your community or the causes that you might want to champion. Now, it does include a little bit of information on climate activist companies that you might want to be involved in or check out, including Paul Hawkins' work with regeneration.org. But again, that's all just there as a resource for you. Thank you, listeners, now and always, for being a part of this pod and this community, because together we really can do so much more. We can care more and we can be better. We can even solve our electrical problems and regenerate Earth. Thank you.
Thanks for listening to Care More, Be Better, a podcast for social good. To make sure you never miss an episode, subscribe, rate, and review wherever you listen to podcasts, and share with your friends to help us reach more people and spread more social good.